MCT4C, we're going to look at the sine law again, and a very specific problem that comes along with the sine law called the ambiguous case. So I'd just like us to look at a right angle triangle for a moment. This triangle ABC has a 27-degree angle of elevation here and a length of 8 here. Just be patient with me as I do a little bit of right angle trig to find and talk about side BC. So if I were going to solve this for BC, I would look at opposite and hypotenuse and set up a sine ratio. Sine of 27 degrees is BC over 8. So to solve for BC, I would do 8 times sine 27. And I would get, I keep doing approximately equal to before I need to. There we go. I would get an approximate answer of 3.63. So, this is what I know. If BC is exactly equal to 3.63, then triangle ABC is a right angle triangle. And there is one solution. However, if the length of BC is not actually 3.63 but shorter than 3.63, then my side BC, because this 27-degree angle and the 8 are locked, then my BC is going to dangle because it won't be long enough to reach the bottom if it's shorter than 3.63. So if I find out that BC is shorter than 3.63, there are no solutions, meaning there are no triangles which fit this data. It just wouldn't work. And the other case is if BC is actually longer than 3.63, I don't have a right angle triangle, but I actually have two possibilities. If BC is longer than 3.63, then BC might go down here and hit the base, because we don't actually know how long AC is. It could be this long. Or longer than 3.63 could bend back and hit AC over this way. So unless we're given more information, if BC is longer than 3.63, there are two possible triangles that would fit this data. So two triangles which fit data. One has an acute angle at C, this guy, and one that has an obtuse angle. This is called the ambiguous case. When we don't have enough data to know which of the two solutions is correct, so we need to consider both. Let's take this triangle. In triangle KJL, angle K is 52 degrees. Little side K is 25 and little side L is 28. So let's choose. I'm going to go with K here, J here, and L here. So that means my little K is here, which is 25. My little L is across the triangle from big L, so it is 28 over here. And little J would be here. The angle that I know is angle K at 52 degrees. Now I really have no idea what this triangle looks like. I've just thrown up a diagram. It is possible that triangle KJL is a right angle triangle. So that's what I'm going to consider off to the side here. If I had sine 52 was opposite over hypotenuse, I would have that as 25 over 28. But I don't know that that's true. So I'm going to compare 25 to 28 sine 52 like I did before and see if that is in fact true. 28 sine 52 is 22.06. So if it were a right angled triangle, then side K would be 22.06. Side K is not 22.06, it is larger. So this is the ambiguous case. Since the side across is longer than a right angled triangle, then K is 25. It's going to go the way I've drawn it, or it could bend back and go that way. The 22.06, which is a right angle triangle, would be right in the middle. But since 25 is larger than 22.06, then I have to consider the ambiguous case. So what I am comparing is K, and I am comparing that to L sine angle K. We'll keep that in the back of our brains. There are two possible solutions. Solution 1 is the KJL the way that I've drawn it with the acute. We're going to proceed as usual, pretending we had no idea there's an ambiguous case to consider. So if I were going to solve triangle KJL with the lengths that I have, I would set up the sine law. Sine of 52 over 25 equals sine of L over 28 equals sine of J over little j. And I want to solve the triangle. So this will take us a little bit of work, but we're going to solve this ratio first, and then we can proceed to solve for j and little j. All right. I am going to get angle L by multiplying both sides by 28. So I'm going to enter 28 sine 52 divided by 25 into my calculator. I will get a decimal. Sine L is approximately equal to decimal 882526, which gives us an approximate value for angle L as 62 degrees. So that means angle J for this solution would be 180 minus the 62 we just found, minus the 52 we were given in the other corner, and angle J is approximately 66 degrees. And I could find my little j from there. So I'm going to use sine 52 over 25 equals sine 66 over j. And I'm going to find little j. I'm going to cross multiply both sides by j, and multiply both sides by 25. And then to get j by itself, I'm going to divide both sides by sine 52. And I get an approximate value for j of about 29. But we know that k may not have bent in that direction. It may have bent the other direction. So let's look. I'll just add another slide in here. So the second solution, and I really like a picture for this, is when I'm going to write the kj the very same. So I've got 28, got k and j, and the 52 degrees, they're locked. The angle between them is 52 degrees, where my little k of 25 could possibly bend back. I don't know. So the other solution is when it looks like that, and my 25 length bends that way. So to solve for this triangle, my start is the same. I'm going to set up the sine law. Sine 52 degrees over 28 equals sine L over 28. Oh, 25, sorry. Equals sine L over 28 equals sine J over J. I want to solve for L. You can tell it's getting silly over here tonight. Here we go. Angle L. Now I know what my calculator is going to give me. I already saw what my calculator was going to give me at the last slide. It gives me 62 degrees. But I know for this particular possibility, when it bends back the other way, angle L is an obtuse angle. So for this triangle, angle L is 180 minus what your calculator gives you, 62 degrees. Your blue cheat sheet that I gave you the possibility that if your calculator gives you one angle, and we're talking about sine of an angle, the other possibility always comes from 180 minus the original. So this is how we get our other possibility for angle L, is to subtract from 180 to get the obtuse possibility. So we are going to get 118 degrees as our other answer for L. So for this triangle, we have 52 degrees, 118 degrees. And to find J, like we did here on the left side, we subtract from 180, but we have some different numbers this time. Angle J is 180, subtract the 52, but this time subtract 118. And J is going to be much smaller. Angle J will be 10 degrees for this triangle. You can see it's long and skinny. That makes sense for J to be very small. To find side J, we set up our trig ratio. I would use sine 52 over 25 equals sine 10 over little j. And I would get a j value of, well, let's write the middle line, j times sine 52, multiply both sides by 25, 25 sine 10, divide both sides by sine 52, and type it in our calculators. And we get, for this one, an approximate value for j, 18.2. Let's summarize on a slide the ambiguous case. When given two sides and a non-contained angle, that means the angle that's not between them. We'll say angle A, little side A, and little side B. If I were given those two sides and angle A is not between sides A and B, we might have the ambiguous case. Then, if little side A is equal to B times sine big A, then we have a right angle triangle and we have one solution. If little side A, or the one that's across from the angle, if it is, smaller than B sine A, we have no solution. I don't know if it's very mathematical, but I think of it as kind of dangly. It doesn't reach the bottom. Too short. If side A is actually larger than B sine A, we have two possible triangles that fit the data, and we need to find them both. And we call this the ambiguous case. our solutions would look like A could go that way to meet the bottom, or the other possibility is when it bends back. So the ambiguous case is when I'm not sure if I have this answer or this answer with differing angles in here. I'm going to do two examples with you. The first one is to solve for side R. First thing to think about is, would I use the sine law on this? Yes, I would, because I have an angle and an opposite side complete. So then I need to look at whether I have two sides and a non-contained angle. Yes, my 30 degrees is not between the two given sides, so I need to consider ambiguous case. Because I use the sine law and non-contained angle. So I'm going to compare A to B sine A, which means the side across from the angle. And I would label it like that. So I'm going to compare 5.3 to 10.6 sine 30. If 5.3 is exactly equal to 10.6 sine 30, I have a right angle triangle, and so on. So let's compare those two things. 10.6 sine 30, if I type it in my calculator, is 5.3. Well, what do you know? Since they're equal, then there is one solution. We have a right angle triangle. And our A value should have been drawn like that. Because it is straight down, it makes a right angle triangle. So I can solve for R that way. Using SOHCAHTOA, 6, I want this guy. I would use tan or cos because I want the adjacent side. So let's use tan. Tan of 30, opposite over adjacent, is 5.3 over R. To get R by itself, I'm going to multiply both sides by R and then divide by tan 30. R is 5.3 divided by tan 30. One answer for R, no other possibility. My answer will be 9.2. I didn't have to draw my triangle like this. I could have just used what I had above and used sine law, but I would have known I had one answer to this problem, and that answer is 9.2. Let's solve for side P. So I need to consider whether I would use sine law for this problem, and I would, because I have a side and angle opposite complete, so that's when we use the sine law. And I need to consider whether the ambiguous case could hold here, and it would because I have two sides and a non-contained angle. The angle between them isn't what I have, so I need to consider the ambiguous case. So what I am comparing for the ambiguous case is 6.7 with 12.4 sine 26. So the 6.7 and 12.4 times sine 26 is what I'm comparing. If the 12.4 sine 26 is exactly equal to 6.7, we have a right angle triangle like the last one. Let's see what we have. 12.4 sine 26 is 5.4. Since the 6.7 is larger than 5.4, then we have a case of the ambiguous case. That means there are two possible solutions. first solution is to solve as we always would. So solution number 1. Set up a sign ratio and trust your calculator. So sine m over m equals sine n over n equals sine p over p. Sine m is 26 degrees over 6.7 equals sine n over 12.4 equals sine p over p. So the first thing I'm going to solve for is angle n just by using the sine law. So I'm going to multiply both sides by 12.4, multiply both sides by 6.7, then divide both sides by 6.7 before I touch a calculator. 6.7. I will get a decimal less than 1 for sine n. About 0.8113. To find angle n, I'm going to second function sine both sides, the inverse sine, and I get an angle of 54 degrees. If I have 54 degrees for n, I can find p by subtracting from 180. I already had 26 degrees, I just found 54, so angle p would be 100 degrees. And little p, I would need to solve another ratio. So I would set up sine 26 over 6.7 equals sine 100 over little p. I'm going to cross multiply and divide. I'm doing this quickly because it is very tedious. You can't do too many in one day, but you have all the sign skills, you're fine. When I type that in, I get an approximate value of p of 15.1. All right, solution number 2. Is with the same given data, so this sine law would be the same. I'm not going to rewrite it, but I know what my calculator is going to give me for angle n. So I know for my second solution, angle n is the other possibility, which is not 54 degrees, but 180 minus 54 degrees. We have 126 degrees for n. So for the other solution, n is different, and so is p. Angle p would be 180 minus the 26, and this time minus the 126. So p is much smaller. These are angles. Angle p would be 28 degrees for the second solution. That will give us a different answer for little p. I am going to solve it using the same ratio that I did before, that sine 26 over 6.7 is equal to sine p over p, but this time sine p is sine 28 degrees. And I don't know why my data keeps disappearing. I'm going to just persevere. It will give me a little value p of 7.2. So a totally different answer than the last one, and apparently wanting to disappear. We have 2 solutions to this problem. So I'm going to ask you to try a couple today. You can't do a lot in one period, but there will be an ambiguous case question on your test, so you need to conquer it. Page 17 for C, 5, 6, 7, 8, 9, and 13.